few graphs, and you're going to have to come up with the equation. So today we're going to focus on getting the A, the B, and the D for the graph. Now remember this, a sine graph and a cos graph are just a 90-degree shift from each other, right? So put it to your calculator, y equals sine x. Type it in. It's your sine x graph, right? And it can keep going, just let's pretend it got real bad. It was good for a second there, and then I destroyed it. But anyways, that's your sine x graph, correct? Your cos x graph starts here, and then it comes down, yes? So it actually is the same graph, but if I move the cos graph, what? How many right? 90. So if I have my y equals sine x graph in my calculator, if I go y equals cos x, I need to move that graph 90 to the right. What am I going to do? How do I move it 90 right? X minus 90 or pi over 2, depending on what mode your calculator's in, correct? So if your calculator's in radian mode right now, put in pi over 2. If your calculator's in degree mode, put in 90. And make sure if you have the TI-83s or TI-84s, you're making that second line thicker. So this would be your Y2. Make this thicker. Remember, go over here and hit enter once. And the reason why you want to do that is it'll sketch the sine x graph, and then it'll sketch the cos x graph. But if you don't make it thicker, you're not actually going to see that it draws over top of it. Correct? So you make your Y2 thicker, and then they'll draw the first one, and then they'll draw the other one over top, and you'll be able to tell it's thicker. Correct? If you don't make it thicker, you can't tell, and you just assume it's drawing it over the top. Or it could be drawing it way below or way above. You could look at the table too. Okay, so cos x graphs and sine x graphs are just a 90-degree shift from each other. If I had y1 equals cos x, and I wanted sine x to land on it, what would I have to make y2 be? Sine what? Yeah, so it'd be x. I want it to go left plus 5. So they're literally just a 90 or a pi over 2 radian shift of each other. We agree? And when we looked at each of the equations, A gave us the amplitude, B came from the period, D came from the midline, and it didn't matter if it was sine or cos, correct? So actually, what we're going to learn today is we're going to find the A for every single one of these graphs from the amplitude. We're going to get the B from the period, and the midline, the D. And we can make 4 equations that represent this graph, guys. We can make a positive sine, a negative sine, a positive cos, and a negative cos. The only thing that will be different on all of the graphs, on all the equations, is your C value, because it's just going to be that shift that has to change depending on what type of graph we have. Okay? For example, negative sine would be here, correct? That's a lie. Negative cos would be here, because it would reflect. Yeah? So then you would end up going like this. So we would just have to shift more to get it to land on top of it. It's the C value that's going to change. So let's talk about the amplitude for this graph. From a graph, how do we get the amplitude from a graph? Absolute value of max minus min divided by 2. Remember I told you to put it on your formula sheet so you know you have to memorize it? Or you can memorize it as half the what? What is amplitude? Half the vertical distance, correct? You count from minimum to maximum, and then you take half of that. That's what the amplitude is. So from here, I'm going from negative 10 to 10. So what's my amplitude going to be? 10, because that's 20. Or we can fill it into here. Absolute value of 10 minus negative 10 divided by 2, which is 20 over 2, which is 10. right? So we can either count the vertical distance and divide it by 2, or we can use the formula. Then flip over. What's the amplitude for this one? Absolute value of what? 2 minus negative 2 divided by 2, which is 4 divided by 2, which is 2. Then flip over. Amplitude of this one. Absolute value of 2 minus negative 2 divided by 2. So it's going to be 4 divided by 2 again, which is 2. And flip over. This one is going to be the absolute value of the max. What's the max? Negative 1 minus the min. Negative 7 divided by 2, which is actually negative 1 plus 7 divided by 2, which is 6 divided by 2, which is 3. We could just count 7 to 1 is 6, divided by 2 is 3, right? It's just a half the vertical distance. Amplitude is always what? Positive. Exactly. Okay, flip. So this one is the absolute value of 3 minus negative 3 divided by 2, which is 6 divided by 2, which is 3. It makes sense because negative 3 to 3 is a distance of 6, and half of that is 3. We're not going to do this one. Okay, go back to the front. What does the amplitude give me on an equation? A, right? The catch is, though, that the amplitude is the absolute value of A, right? So if my amplitude of this one is 10, I could actually have an A value that's negative 10, and A value that's positive 10. And the absolute value of those would give me an amplitude of 10. You agree? So down at the very bottom, we're going to start writing our equations out. We're going to get 4 equations for every graph, just so you know. Now you might be like, why do you have to find 4? Because I can ask for any of them. I can ask for a positive sign or a negative sign or a positive cos or a negative cos. So why not find all 4, and then it doesn't matter what I ask you, you can find it. Okay? So our equations are going to be y equals 10 sine, y equals negative 10 sine, y equals 10 cos, y equals negative 10 cos. Because amplitude doesn't restrict me, right? It gets me 4 equations, positive sines, 2 positive and negative sines, and a positive negative cos. We agree? Does that make sense what we're doing? Because the absolute value of all those A's would still give me an amplitude of 10. We agree? Okay, next page. This one has an amplitude of 2. So we're going to get y equals 2 sine. Y equals negative 2 sine. Y equals 2 cos. Y equals negative 2 cos. Then we're going to flip over again, and we're going to do this for each one. This one has 2 again, so y equals 2 sine. Y equals negative 2 sine. Y equals 2 cos. Y equals negative 2 cos. This one was 3. So we get y equals 3 sine. Y equals negative 3 sine. Y equals 3 cos. Y equals negative 3 cos. The next one is 3 again. So y equals 3 sine. Y equals negative 3 sine. Y equals 3 cos. Y equals negative 3 cos. Let me go back. All right. The next thing we need to find from a graph is the period. Is the period the period? Period is P, correct? Do you see like P equals period? Yeah? Do we have a P in our equation? We have an A, a B, a C, and a D in our equation, correct? Do we have a P in our equation? No. Do you know how many times they're going to put P in for B, and that'll be an answer? You guys are going to pick it? It's common error that you put period in for B. But does period start with a B? No, that would be a period, which is not even real. I made it up. Okay? So let's find the period of this graph. What is the period of this graph? When we want to find the period, we can go from a max to a max. We can go from a min to a min. If we went from a max to a min, what would that give us? Of a period. Half. We just have to times it by 2. Correct? So it's the horizontal distance to make us repeat ourselves. From a max to a max, a min to a min, or from a y-axis till it repeats itself. So if I start at the y-axis here, I'm at a maximum. I'm going to have to go back past a min, back up to a maximum, and then what's going to happen again? It's going to repeat itself, correct? So how long horizontally does this graph take to repeat itself? 4 pi. So what is this graph in? Radians or degrees? Radians, because the x-axis is in radians. So I'm going to write that for myself so I know that, and I remember that. So the period is 4 pi. Awesome. Do you know what? They'll put 4 pi in for B. I love when they do that. I'm like, it's wrong, and I cross it off. 2 of my multiple choice are done. I at least have a 50-50 chance at that point. You just remember that the period is not B. You can cross those ones off because they put the period in for B. Done. 50-50. I like when they do that because I'm like, thank you very much. I'm not picking those. Okay? They will be picked more than the correct ones. All right. Let's go find the period of the next graph. So you can either go from a max to a max. So you could go from 0.75 to 1.75. Or you could start at the y-axis at this height. Everyone paying attention? You start at the y-axis, you have to go past the max, past a min, back to that same height. Or past a min, past a max, back to that same height, right? Before it starts repeating itself. So what some people do is they'll come here, and then they'll stop. And then they'll say, okay, it's going to repeat itself. Has it actually repeated itself yet? We went past a max, but we still have to go past a min, and then back up to here. If we went from 1.75 or 0.75 to 1.75, that's a max to a min. That's 1 pi. I would have to times it by 2 and get 2 pi. So it would still give me the same answer, correct? If I had went from that maximum to the minimum. Either way, but this here, going past a max, past a min, repeats itself at 2 pi. So that's the P. The period is 2 pi, not the B, correct? Guys, if the period is 2 pi, what is our B? What is our horizontal stretch? Is there one? No, but you feel 1, right? Because that means it didn't stretch, didn't get wider or narrower. All right, let's go to the next one. This one, the y-axis starts at a min. I can go from a min up to a max. I should have wrote radians on the last one too. Down to a min. What's this repeating itself at? It's actually 0.666666 because it can't be 0.67 because it's 0.33. So this is 1/3. This is, we're going to mark these as 1/3 and 2/3. Because these decimals are stupid. What is this x-axis in? Radians or degrees? Radians, how do you know? There's no degree symbols. That's literally how you would narrow it down. So this is radians. So is the previous one. I have to go back and put that. And this thing repeated itself in 2/3. Okay. Assume we can start at a max. We'll pass a min. Back up to a max. And how long horizontally is that? 4. And what's this in? Radians or degrees? Radians, because it doesn't have a degree symbol. Is that the last one? Nope. Okay, let's go through this one. Start at the Y. Go past a min. Stop. Keep going past the max. Back down to this height. What is it? How long horizontally? 4 radians. Yeah, this is in radians. All right. So let's go back to working with our equation. So the period, is that the period? Is the period the b value? No. How do we get the b value? Remember, period equals 2 pi over b. If I want the b, what could I do? Swap them, right? So b equals 2 pi over p. And why am I using 2 pi and not 360? Because it's in radians. The x-axis was in radians, right? So I go 2 pi divided by 4 pi. And what is my b? 1/2. So I go down to this equation. And remember, if you look here, it literally shows you the format they need. A sine b, c, d, right? You can use square brackets if you want. Or round, doesn't really matter. So we go b, 1/2. This one's going to be b, 1/2. Do you see how the b doesn't change? 1/2. Does it make sense that it's a half? What would my horizontal stretch be? 2. So it went from 2 pi to 4. Oh, makes sense. Right? Like the period is 4 pi now. Double. Okay, next page. So this one has a period of 2 pi. Okay, cool. B equals 2 pi divided by P. B equals 2 pi divided by 2 pi. What is my B? 1. Why is it a 1? Because 2 pi is the original period, and if it's still 2 pi, it's 1. So we go to our equations. We get 1. Let me flip over. So this one has a period of, this one gets people. So the B equals 2 pi divided by P. Now remember, our B has to be 2 pi over P because it's in radians, because the x-axis doesn't have a degree symbol, right? The other ones had pi, so the pi's canceled off and our B didn't have a pi in it. This B is going to have a pi in it, correct? Because my period is 2/3. So I'm going to get, 2 pi divided by 2/3. Which is a stacked fraction. So I can go 2 pi instead of divide by 2/3. I can multiply by 3/2, which is 3. Can you put fractions in your calculators and get them back out? Yes, if you don't put in the what? The pi. The moment you put the pi in, fractions will never come back. So this one's 3 pi. That's my B, so I go 3 pi. Bless you. Okay, this one has a period of 4. So your B equals what? What do we do? 2 pi over 4. So it's pi over 2. So do you see that the period being 4, if you put that in for b, it's immediately done? That equation would be wrong. So as long as you remember the period and the period are not the same thing. So it's pi over 2. This one has a period of 4, so the period, or the b value, is 2 pi divided by 4 again, or pi over 2. And then we're done. Okay, go back. I told you the only thing that changes is the c. Each equation will have a different c, because it'll have a different horizontal shift to make it land on top of each other. Because literally they have the same amplitude, they have the same period, they have the same midline. The only thing that makes them that graph is by moving them this way or that way to make it land on top, correct? So let's talk about midlines. Midline is the line that cuts the graph in half. It's the average between the max and min. So if I want the average, I add them up, divide by 2, correct? So this one is symmetrical about the x-axis, so that'll help. But our midline is going to be max, which is 10, plus min, which is negative 10, divided by 2, which is 0. Remember, our midline is y equals 0. Don't forget the y equals part. Yeah? What's the midline of this one? We have 2 and negative 2. So it's going to be 2 plus negative 2 divided by 2, which is 0 divided by 2, which is 0. But it's a midline, so we go y equals 0. Yeah. Flip it over to the other 3. So the midline for this one is between 2 and negative 2. We do 2 plus negative 2 divided by 2. 0 divided by 2, which is 0. Make sure you have y equals 0. And then this one is negative 1 and negative 7. So you do negative 1 plus negative 7 divided by 2 is negative 8 divided by 2, which is negative 4. So we get y equals negative 4. And then this one is 3 and negative 3. So we get 3 plus negative 3 divided by 0. That's alive, divided by 2. 0 divided by 2 is 0. So let's go back to example 1. Every single one of you is going to draw the midline on here because it's going to be helping us for sine graphs for the c values tomorrow, not right now. So we're going to go in and we're going to draw our midline. The midline for this one is y equals 0. So that's here. Everyone needs to draw it. Then what I need you to do is bold, make bold points where it intersects with the graph about the y-axis. So I'm going to put one here and one here. That's for tomorrow. So you draw your midline, and then you bold where the graph intersects with it about the x-axis. Okay? Next graph. This one is y equals 0 again. I'm going to draw my midline. And then I'm going to bold where it intersects about the x-axis. So one is here, and one is here. Do you see what I'm doing? Opposite sides of the y-axis, where they cross it up. Midline's important to draw because it has to intersect with the midline. Okay, next one. The midline is where? Y equals 0 again. Then I need to bold where it intersects with the graph about the y-axis. Here's the y-axis. It intersects on this side right here. Intersects on this side right here. Then the next one is actually at y equals -4. So I go to -4 and draw a horizontal line. Now where does it intersect with the graph about the y-axis? Here and here. That's for tomorrow for the c values. And then the last one is y equals 0 again. It's symmetrical about the x-axis. And then this one you have two choices. You can pick this one because it's on the y, and then technically this and this. But we'll talk about those tomorrow. What does our midline give us of the equation? The d value. Which of these equations has a d value? Or which of these graphs? This one. This is the only one that's going to have a d value. Because it's the only one with a midline that isn't 0. So could I go back to every single one of the equations and put +0 at the back of each of them? Technically, can I just put a +0? Sure, is it wrong? No. Will they have +0 as an option in a multiple choice numeric? No. But if you wrote it in a written response and you put +0 at the back, you're not wrong. You just don't need it. So the only one that needs a number at the back is example 3. It needs to have that -4. See what I'm saying? Whereas all the rest had midlines of 0. So example 3 is the only one with a midline that wasn't 0. It was -4, this is example 3. Let's say I go to example 4. Example 4 is a midline of 0. So I can, if I want to, I can do this. No harm in it. So does everyone see where I got the A, the B, and the D from? The C for all 4 equations will be different. Because technically you have the same graph drawn, you just need to shift it to make it land on the ones that are reflected and the ones that have stayed the same, which ones that are coses and ones that are reflected coses, which we'll talk about tomorrow. Okay? So you have no homework on this because I want you to get down to 15 in that booklet. I'm going to come around and check it too. I'm going to give you a homework check if you tried this stuff.